In this video, we're going to look at an example where we use either interpolation or extrapolation. So before we come to those two words, let's just read this. We can also use a regression line of y on x to predict or estimate the value of the dependent variable, that's y, when we know the value of the independent variable, which is x. The accuracy of this prediction is increased when the sample size is large. So the bigger the sample size, the more accurate our prediction is likely to be, and if the data is randomly selected as well. So if that is true, then our predictions should be as accurate as they can be. So now for these two words, interpolation and extrapolation. Interpolation is using the model, so using the regression line, to make prediction within the given range of the data. So if the data has x values from 0 to 100, for example, then we can use the model to predict the corresponding y value for any x value within that range 0 to 100. Now, interpolation is generally reliable. However, extrapolation, which is making predictions outside the range of data, that makes our estimate much less reliable. We can't say it definitely isn't accurate. It's possible that extrapolated predictions could be accurate. The problem is we can't be sure, so it's much less reliable. And one other thing, we cannot use the regression line of y on x, which is where y is the equation. Y is the subject of the equation. We cannot use that line to make a prediction of the value of x when we know y, so you can't work backwards. So regression line of y on x is of the form y equals ax plus b, or a plus bx. In other words, y is the subject of that equation. So let's go on to example 4.2.4 now. Please pause the video and read the full question. Right then, part A, interpret the values of 75 and 1.43 in context. In section 4.2, this is the third time now we've interpreted both of these values in a regression line. So hopefully you're good at this by now. The 75 is the value of h when t is 0. So now put that into context. If the temperature was 0 degrees Celsius, we would expect the humidity to be 75%. Notice I've included this units there. So not just numbers, but units as well, must be in context. And the 1.43, going back to the regression line, if t increases by 1, then h increases by 1.43. Now put that into context and include units as well. So for every 1 degree Celsius increase in temperature, the humidity increases by 1.43%. Part B, the humidity in the sample ranges from 78% to 98%. Explain why it would not be sensible to use the regression equation to work out the value of h, or to predict the value of h when t is 30 degrees. So we know the humidity in this sample goes between 78% and 98%. We don't know what the temperature went from, what ranges it went between. So let's just go ahead and put t as 30 into the regression line and see what we get. So if we let t equal 30, we get h is at 117.9%, which is greater than the highest humidity in the sample, and therefore it's outside the range of this data. This is an example of extrapolation, and hence may not be reliable. So it's not sensible to use our regression equation to predict the value of h when T is 30. So I'd just like to recap. In that example, we knew the humidity in the sample ranged between 78% and 98%. We weren't told what the temperature ranged between. That's why we had to work out, if we did go ahead and use a t-value of 30, what h value would it predict, which is outside the range of data. Therefore, that's extrapolating and hence may not be reliable, which is the reason it's not sensible to use the regression equation in that situation. Part C, comment on the suitability of Bob's method and suggest how he could make a better use of the large data set. Well, he's studying the relationship between temperature and humidity in the UK. It doesn't say for a particular month in the UK, it just says in the UK. Also, it doesn't say a particular location. So he's only sampled 7 days from 1 month. He's sampled from May. So his method will not be suitable for the UK in general. It's not going to tell us anything about the rest of the year. Also, he should sample from more months and in more locations. The question doesn't tell us how many different locations he uses, but if he used as many locations as possible in as many months as possible, then that would be a much better method for determining the relationship between temperature and humidity in the UK.